we need to obtain the sum to n terms of the given series. Now this is neither an arithmetic series nor a geometric series, but we can convert it to a geometric series. So let's begin. First, we will expand each of the terms. So we have x plus 1 over x whole squared. So its expansion will be x squared plus 2 plus 1 over x squared plus x squared plus 1 over x squared whole square. When we expand the second term, we're going to get x raised to the power of 4 plus 2 plus 1 divided by x raised to the power of 4. Then expanding the third term is going to give us x raised to the power of 6 plus 2 plus 1 over x raised to the power of 6. This goes all the way up to the nth term. So expanding the nth term, we're going to get x raised to the power of 2n plus 2 plus 1 divided by x raised to the power of 2n. Now what we'll do, we will combine the first term of each of the terms. So this is going to give us x squared plus x4 plus x raised to the power of 6 all the way up to x raised to the power of 2n. So total there will be n number of terms. So we'll combine them and keep it aside. This will be added to the second terms of each of the terms, which is 2. So we have 2 plus 2 plus 2 added to itself n number of times. Then we come and add the third term of each of the term and combine it together to get 1 over x squared plus 1 over x raised to the power of 4 going all the way up to 1 over x raised to the power of 2n. Now we will see that each of these sum will be a geometric progression. For the first sum, our first term, so that's the first term, x squared. The common ratio r is going to be equals to x raised to the power of 4 divided by x squared. So it's going to be x squared. Coming to the second one, so this is a geometric progression, but we can simplify its sum. So it's 2 added to itself n number of times. So it's going to be 2 times n. Then we coming to the third sum. So here the first term, so this is our first term, which is 1 over x squared, and the common ratio is 1 over x raised to the power of 4 divided by x squared. So this is going to be 1 over x squared. Now that we have the first term as well as the common ratio, we can obtain the geometric series or the sum up to the n term. So here we will have x squared multiplied to the common ratio, which is x squared, raised to the power of, so here we have total n number of terms. So it will be raised to the power of n minus 1 whole divided by the common ratio x squared minus 1 plus the second term, which is 2n, plus coming to the third term, which is the sum, will be given by the first term multiplied to the common ratio, which is 1 over x squared whole raised to the power of n minus 1 divided by the common ratio 1 over x squared minus 1. Further simplification is going to give us x squared multiplied to x raised to the power of 2n minus 1 divided by x squared minus 1 plus 2n plus. So here we have 1 over x squared. So let's try to do it separately here. In the numerator we have 1 over x squared whole divided by, so 1 over x squared minus 1. So that's 1 minus x squared divided by x squared. This gives us 1 over 1 minus x squared. Now this will get multiplied to, coming to the expression 1 over x squared whole raised to the power of n minus 1. This can be also expressed as 1 over x raised to the power of 2n minus 1, which becomes equals to 1 minus x raised to the power of 2n divided by x raised to the power of 2n. And that means we will have 1 minus x raised to the power of 2n divided by x raised to the power of 2n. Furthermore, what we can do, we can multiply both the numerator and the denominator with negative 1. So we're going to multiply negative 1 to both the numerator and the denominator such that it now becomes, so let's write down the first term. So that's x squared times x raised to the power of 2n minus 1 divided by x squared minus 1 plus 2n. So negative 1 multiplied to the numerator portion. So that's going to become x raised to the power of 2n minus 1 divided by, so we have x raised to the power of 2n. So we'll write it first. This will get multiplied to negative 1 times 1 minus x squared. So we have x squared minus 1. Now what we can do, we can combine the first term and the third term by taking x raised to the power of 2n minus 1 divided by x squared minus 1 as the common factor. So this will now get multiplied to x squared plus 1 over x raised to the power of 2n. plus 2n. So this is going to be the sum up to the n terms of a given series.